Albert Einstein was born on March 14th, 1879, in the city of Ulm, which is in southern Germany. At that time, Ulm was an important city in the Kingdom of Württemberg, a major part of Germany in the late 1800s. His father, Hermann Einstein, was an Ashkenazi Jew from a town called Buschau in Württemberg. Hermann was very smart and did well in applied mathematics while he was studying in Stuttgart, Württemberg's capital, as a young man. However, the Einstein family did not have a lot of money, so he had to stop his education and work in a featherbed store owned by his cousins, Moses and Hermann Levi, in Ulm during the 1870s. Albert's mother, Pauline Koch, came from a family of German Jews who had many connections as merchants in Württemberg. She married Hermann Einstein in 1876, and Albert was their first son. 2 years later, in 1881, they had a daughter named Maya, or Maria Einstein. A lot of Albert's early life was influenced by his father's business activities. When Albert was just a baby, Hermann Einstein, after taking his brother Jacob's advice, decided to relocate the family to Munich, the largest city in southern Germany, about 170 kilometers east of Ulm. This move took place in 1880, as Jakob and Hermann wanted to start an electrical engineering company called Einstein and Cohesion Munich, right as the major transition to electricity was beginning to happen worldwide. In Munich, Albert attended a Catholic elementary school before transferring to Luitpold Gymnasium in 1887. He stayed there until 1894, but at that point, the family had to move again after Hermann and Jakob could not get a deal to electrify Munich. They then moved to northern Italy, first living in Milan and then in Pavia. Albert stayed in Munich briefly to keep studying, but after a few months he became frustrated with the strict learning style at the gymnasium and convinced his parents and school officials to allow him to join them in Italy. Starting in 1894, Albert continued his schooling in Italy. He was already demonstrating a remarkable talent for science and mathematics, although his father wanted him to focus more on practical engineering to help out with the family business. During the summer of 1891 in Munich, he taught himself algebra and the advanced geometry of Euclid, an ancient Greek mathematician. The Einsteins hired a private tutor named Max Talmud, who was skilled in optometry and ophthalmology, to teach Albert higher-level mathematics and science. However, Talmud quickly realized that Albert was learning faster than he was in subjects like calculus, algebra, and geometry. He wasn't just a genius interested only in science and math. As he grew into a teenager, he also started reading a lot of the most challenging philosophical authors from the 18th and 19th centuries, especially the German thinker Immanuel Kant. Kant's book, Critique of Pure Reason, first released in 1781, provides a detailed examination of metaphysics, which looks into the nature of reality. This book is one of the most complicated philosophical works ever written, but Albert seemed to grasp it well by age 14, surprising his tutor. Young Einstein's talents were recognized by his teachers, tutor, and parents. Soon after moving to Pavia and after turning 16, he was sent to take the entrance tests at the Swiss Federal Polytechnic School in Zurich, a top school for science, math, and engineering. Even though he did well on the technical tests, Albert was not accepted because of his young age. The next year he passed the Swiss Matura, an exam for students who hadn't attended school in Switzerland but wanted a secondary education equivalent. Earlier that year, he had also given up his German citizenship to avoid being drafted into the mandatory military service for young men in his country. Therefore, as someone without a nationality, he finally enrolled in the Polytechnic School in Zurich in the fall of 1896 at the age of 17. There, he would study physics and mathematics, the two subjects in which he had shown great talent since childhood. He would spend 4 years there, eventually earning a diploma in 1900. Einstein's time in Zurich was when his research interests really started to take shape. He was becoming a versatile scientist who could mainly be called a physicist, but whose knowledge spanned many topics, like finding an accurate method to measure tiny molecules, which is part of quantum mechanics, the science that explains the physical properties of matter at atomic and subatomic levels. He was also interested in how light moves. When he began to research this complex topic in Zurich around the start of the 1900s, most scientists in Europe and North America believed that light traveled only in wave patterns. However, as would become clear later, Einstein wasn't convinced by this theory. He thought there was more complexity to how light traveled. These topics and others in advanced physics were central to Einstein's studies in his mid-20s. They became the basis of his doctoral dissertation, which he worked on part-time in the early 1900s and completed in 1905 in Zurich, called A New Determination of Molecular Dimensions. His studies in the early 1900s were clearly supported by Mileva Marić, a young Serbian who studied math and physics and began going to the Polytechnic School in Zurich around the same time Einstein started teaching there, after finishing first in his class in 1899. Marić was one of only 2 women studying at the school during that period. She and Einstein soon began a romantic relationship, and it is now believed that she helped with his research, though how much she contributed remains uncertain. Regardless, her own studies were interrupted in the summer of 1901 when she became pregnant. At that time, Marić and Einstein were not married, and having a child outside of marriage was still seen as shameful. It is thought that Mileva went back to Serbia to have the baby, whom they referred to as Lizerl, in their letters after her birth. It seems likely that she passed away since Marić and Einstein got married in January 1903. They later had 2 more children, a son named Hans Albert, who was born in the summer of 1904, and another son, Eduard, born in 1910. It may seem strange now, but Albert did not find it easy to get a teaching job right after finishing his diploma in Zurich in 1900. For the next year and a half, he tried unsuccessfully to get a junior faculty and research position at a university in Central Europe. In the meantime, he became a Swiss citizen in 1901, finally gaining nationality after being stateless for nearly 5 years. With his Swiss citizenship, a family friend from Polytechnic, Max Grossmann, helped him get a job at the Swiss Patent Office in Bern. In this role, Einstein worked as an assistant to a patent examiner. This meant that Albert was responsible for evaluating the worth of different inventions and devices submitted to the patent office by people hoping to protect their creations and ensure they receive financial rewards for their ideas. Einstein stayed in this job for several years, focusing on many types of inventions related to electrical conduction and mechanics. It has been suggested that this experience influenced Einstein's own research during his early career. While finishing his doctorate and working at the patent office in Bern during the early 1900s, Einstein was writing several papers to be published in Annalen der Physik, a major scientific journal for physics, which had been published in Germany since 1799. This eventually led to the publication of 4 distinct research papers in that journal in 1905. Each of these papers made significant contributions to different areas within the study of physics. Together, they have been seen as transforming how humans understand the tiny structures of the natural world and the rise of new physics. The first of Einstein's 4 papers from 1905 was called A Simple Perspective on the Creation and Change of Light and came out on June 9th. This paper introduced the idea known as the photoelectric effect for the first time. The photoelectric effect describes how electrons are released when light or other forms of electromagnetic radiation hit a material. The electrons that get released in this way are referred to as photoelectrons. Before 1905, when Einstein explained the photoelectric effect, most physicists thought light moved like ocean waves. However, Einstein showed that light also traveled in what he called distinct energy packets, which moved together without splitting apart and could only be absorbed or produced as whole units. This not only clarified many unknown aspects of light and electrons, but also had crucial importance for understanding how light with a specific frequency could provide enough energy to free an electron. This was based on earlier work by physicists like Max Planck, but Einstein's paper included a lot of new information about how energy and light interacted through the photoelectric effect. This had significant effects for practical physics. Just 6 weeks after this first paper was released, Einstein's second paper from 1905, titled On the Movement of Tiny Particles Floating in a Still Liquid as Needed by the Molecular Kinetic Theory of Heat, was published in Annales der Physik on July 18th. Before Einstein's paper, there was no precise method to measure the size of molecules, but some scientists in the 19th century, like John Dalton, had observed that chemicals tended to combine or separate in specific weight ratios, indicating that they were all constructed from a yet unknown type of physical molecule common to all substances. Einstein's second paper from 1905 explained how to better measure atoms through something called Brownian motion, where tiny particles, like pollen grains, float in water. This paper, along with a supporting study by French scientist Jean Perrin in 1908, clearly proved that atoms and molecules indeed exist and are the essential components of everything around us. Therefore, this paper was an important step in helping people accept that atoms and molecules are real, paving the way for atomic theory to become a key part of physics in the 20th century. Einstein's third paper was published a little more than 2 months later, on September 26, 1905. This work was called On the Electrodynamics of Moving Bodies, and dealt with the idea of special relativity. The focus was on solving a problem linked to an equation created by Scottish mathematician James Clerk Maxwell in the early 1860s concerning electricity and magnetism. Maxwell's equations created confusion for physicists trying to understand how mechanics work at speeds close to that of light. To address this, Einstein presented his special theory of relativity in his 1905 paper. This theory says that the speed of light is constant for everyone, no matter how the light source or the observer is moving. This directly challenged Isaac Newton's belief from over 200 years ago that light's speed is not fixed. Furthermore, Einstein's theory correctly pointed out that when two objects relate to light, it becomes impossible to truly know which object is in motion and which one is still. Einstein had this insight while riding a streetcar in Bern during early summer 1905 and watching the clock tower in the city center. He understood that if the streetcar suddenly traveled at the speed of light, the hands of the clock on the tower would seem to stop, even though the clock inside the streetcar would keep moving normally because both he and the clock in the streetcar were moving at the same speed. So, the speed of movement is relative. If the streetcar accelerated to light speed, it wouldn't mean the clock tower had actually stopped. It would only seem that way compared to the speed the streetcar was now moving. This is how the special theory of relativity works. Einstein's fourth and last paper of his Annus Mirabilis came out on November 21st and was called, Does the Inertia of a Body Depend Upon Its Energy Content? Few people know this title today, but many are aware of the famous equation that Einstein introduced in this paper, E equals mc squared. In simple terms, this equation states that the energy, E, of an object at rest is equal to its mass, m, multiplied by the speed of light squared. This equation demonstrated that a large particle has something called rest energy, which is different from its kinetic energy. This idea became known as mass energy equivalence and shows how the rest energy of a particle, like the nucleus, can be so great that if the particle is disturbed enough, it can release a huge amount of light and heat energy. As we will observe, applying this equation had very harmful outcomes. In later years, Einstein came to regret this side of his work. Einstein's 4 papers that came out in 1905 were not just important discoveries in the small world of theoretical physics. His studies changed how science was applied to everyday life in the years that followed. For example, when you approach an automatic door today, and it opens for you, it happens because the sensors in the doorway react when the light beams, or photons, are blocked by a person walking by. The sensor then instructs the door to open. Einstein was the first to explain how photons function. Solar-powered calculators and street lamps that automatically turn on at night are just a few of the advancements that came from his research on light. The special theory of relativity eventually contributed to the creation of global positioning systems, or GPS. So, when you open Google Maps, it is, in part, working based on the research published in Einstein's remarkable papers. And when a nuclear power facility generates a lot of energy by using the energy located in the nucleus of an atom, they are relying on Einstein's findings about energy and mass equivalence in the equation E equals mc squared. Einstein's groundbreaking research, published in 1905, quickly caught the attention of the European scientific community, even though during that time, people still depended on physical copies of journals and spoken communication to share research. It took several years for the significance of his discoveries to be fully recognized across Europe. As this recognition grew, it changed his career. By 1908, he got a teaching job at the University of Bern and was able to leave his job at the patent office. The following year, he was given a new position in theoretical physics, specifically created at the University of Zurich. He stayed there for the next 2 years. During this period, he continued to improve some of the ideas he presented in his 1905 papers, while also starting to develop the theory of general relativity as a continuation of his work on special relativity. The general relativity theory states that the visible pull of gravity between two masses comes from the bending of space and time caused by those two masses. This research made significant early contributions to the study of black holes and different types of matter in the cosmos. In 1911, Einstein departed from Switzerland, where he had lived for more than 15 years, to accept a new job at Charles University in Prague. At that time, this university was the oldest in what is now the Czech Republic, but it was still part of the Austro-Hungarian Empire. Simultaneously, he was offered Austrian citizenship. Even though he stayed there for just over a year, he published more than 12 papers discussing issues like radiation mathematics, quantum theory, and gravity. Soon, however, another opportunity brought him back to Switzerland. He received an invitation to teach at his former school, the Polytechnic School in Zurich. By the summer of 1912, he was there and spent the next year giving lectures to students who were becoming more aware of the rising prominence of the German physicist, while also delving into subjects related to gravity and molecular heat. Much of his research was conducted alongside Marcel Grossmann, a Swiss colleague who had studied at the Polytechnic with Einstein in the late 1890s, and whose family had helped him secure his earlier job at the Bern Patent Office. In the spring of 1913, less than a year after starting his job in Zurich, Einstein was visited in Switzerland by Max Planck and Walter Nernst, two leading scientists of the time. Both were based in Berlin and traveled to Zurich to persuade Einstein to return to his homeland for a role at the University of Berlin. This new position included automatic membership in the Prussian Academy of Sciences, along with a role as the head of the Kaiser Wilhelm Institute for Physics. This would let Einstein focus on his research and build a team of researchers around him. The offer was too good to pass up, especially since it meant he could be near his cousin, Elsa, who lived in Germany, and with whom Einstein had started communicating regularly since the spring of 1912. Therefore, early in 1914, Albert moved to Berlin. His first wife, Mileva, initially agreed to join him, along with their 2 sons, but she quickly felt unhappy in Berlin, suspecting that Albert was growing closer to his cousin. Just shortly after, she decided to return to Zurich with their children. They remained apart until 1919, when they finalized their divorce, after which Einstein married Elsa. By that time, both he and Elsa were in their 40s, and this second marriage did not result in any more children, though Albert became a stepfather to Elsa's 2 daughters from her previous marriage. Einstein's arrival in Berlin was soon overshadowed by the start of World War I. For years, tensions had been escalating among the major European nations over diverse issues, including colonial competition in Africa, the decline of Ottoman power in the Balkans, and the naval race between Britain and Germany. All these factors converged in the summer of 1914 into the start of a big war across Europe, which quickly turned into a global battle. When it started, Germany's attack on neutral Belgium to move swiftly into northeastern France was met with widespread global disapproval. Soon, a paper called the Manifesto of the 93, aimed at the civilized world, was being distributed in Germany. This action was led by notable people like Adolf von Baeyer, who won the Nobel Prize in Chemistry in 1905, and Paul Ehrlich, known for his groundbreaking work in chemotherapy and awarded the Nobel Prize in Medicine in 1908. This document was basically a letter from many prominent German scholars showing their backing for Germany's war campaign. Einstein, who was always against violence, chose not to sign it and, along with a few other German scholars, created the Manifesto to the Europeans. This document conveyed the notion that Europe could unite through its shared culture to bring peace. The war ended quickly. Sadly, their dreams were shattered, and the conflict continued for 4 more years of endless battles, followed by additional years of revolutions and civil wars throughout much of the continent. Despite the ongoing war, Einstein started new research in Berlin from 1915 as the initial shock of the war began to fade. However, the Kaiser Wilhelm Institute was not finally created in Berlin until 1917, with Einstein as its first director. The war effort caused various funding and administrative delays that postponed its opening. He would lead the institute for the following 16 years. During this time, in 1916, he became a member of the German Physical Society, founded in 1845 and recognized as the oldest significant group of physicists in the world. In the upcoming years, he would also receive international honors, such as joining the Royal Netherlands Academy of Arts and Sciences in 1920, and being accepted as a foreign member in 1921 to the Royal Society, which is often seen as the most prestigious science organization and has roots going back to 1660 when it was established in London. Apart from these accolades, Einstein made significant advances in his research during the mid-1910s. For example, in 1916, he theorized about the existence of gravitational waves, which are like ripples that occur in the fabric of space-time. These waves could not be detected with the technology available in the early 1900s. But in 2016, exactly 100 years later, American scientists finally confirmed their existence. He was also starting to theorize about what we currently call black holes, places in space where gravity is so intense that nothing, not even light or particles, can escape, and they warp space and time. Similar to many other topics, his pioneering research on black holes opened the door for many future scientists to explore the fundamental elements of the universe in the later 20th century. He might, however, also be wrong. In 1917, he started to develop what he called the cosmological constant, a concept that assumed the universe was unchanging. Years later, when American astronomer Edwin Hubble found that galaxies were moving away from each other, Einstein understood that his previous idea of the cosmological constant was wrong, and he called it his, as he put it, greatest mistake in his whole career. Despite this, his other significant research work during the war times was anything but a mistake. This concludes the first part of the documentary. If you enjoyed it, stay tuned for the second part. I hope you found this video helpful and inspiring. If you enjoyed it, don't forget to give it a thumbs up and subscribe for more content like this. Share your thoughts in the comments below and let me know what topics you'd like to see next. Thank you for watching,